All right, so now we are going to solve the equations from quiz 11 that was taken on March 4th of 2025. So that is today. And we're just going to go ahead and solve these. So in the last video, remember we found our pK1 and our pKa2 values here. And we talked about the association between Ka1 and Kb2. Okay, and how you multiply those to get Kw, which means that if you do Ka2 times Kb1, that's going to give you Kw, right? So this is the relationship that we have to remember for the diprotic acids and bases. Right, so the first one is we have our intermediate species and we are looking for a pH. So we are going to take 1/2 and we're going to multiply that by pKa1 plus pK2, and I'm going to run those numbers and we'll see what we get. All right, so when we run that math, we're going to get 6.41 as our pH for part A. Now, part B, we have got 0.037 molar of H2Q, right? So we've discovered, or we talked about earlier, how we're going to set this equal to Ka1, and we're going to solve this equation. Now, this is a multi-step equation on here, because first of all, we have to solve for x. But then we have to realize that x is going to be equal to our hydrogen ion concentration, and then we have to plug that into our pH formula in order to solve that. So in solving for x, we're going to multiply both sides by H2Q, and then we're going to square root this side over here to get x by itself. So we're going to put x is going to equal the square root of Ka1 times H2Q. Right, so let's run those numbers and then we'll solve for our pH. Right, so when we run those numbers, we're going to get x is equal to 9.618 times 10 to the negative 4. And again, remembering that x is going to be our hydrogen ion concentration, we are going to plug that into our pH formula, which, if you'll remember, pH is the negative log of our hydrogen ion concentration, and that gives us pH is equal to 3.017. But we're going to remember our significant figures, and we're going to round that up to 3.02. Now, for the next part, remember we talked about last video how we have to solve this for the number of moles. So for HQ minus, we are going to take 0.250 liters. And what I did here was I just converted milliliters to liters. And we're going to multiply that by our concentration. And that's going to give us our concentration, or our moles of HQ minus. And we're going to do the same thing for Q minus 2. And I'm just going to go ahead and write this in. And then I'll run those numbers so that we've got them. All right, so it looks like this is what that gives us. HQ minus is 0.00925, and then Q2 minus is 0.0074. So we are going to plug our numbers that we have into this equation. So our pH is going to be equal to pK2, which we solved for up here, and that is going to be 8.215 plus the log of, and we put Q minus 2 on the top. Okay, so that is going to be 0.0074 over 0.00925. And I'm going to run that number and get it on here. Right, and this is going to give us a pH equal to 8.118. And again, we're going to remember our significant figures here. And we're going to round this to 8.12. And we're going to do the same thing down here. First thing we're going to do is we are going to solve for the number of moles. So we've got 0.25 liters times 0.037 moles per liter of HQ minus, and then 0.200 liter times 0.037 moles per liter. And our liters are going to cancel. That's how it's going to give us moles. And I'm going to run those numbers, and I'm going to pause this. Right, so we have our number of moles now. And we're going to look at our equation, and we looked at this earlier, and this is going to correspond with our pK1. And we solved for that up here. Our pK1 is 4.608. So our pH is going to equal 4.608 plus the log of, we have to put HQ minus on top, 0.00925 over 0.0074. And this is going to give us, make sure you guys can see this, a pH equal to 4.704. And again, we're going to remember our significant figures, and our pH, this time we're going to round down though, is going to equal 4.70. If you guys have any questions, drop it in the comments, send me an email, catch me after class. I really hope that this helps, and we'll go over some of the stuff that we're going to do on Thursday here in a bit. Thanks.